Hi, this is Mr. Kerr. In this video, we're going to be looking at what makes something soluble. So I just want to review the structure of water. So remember that water has polar covalent bonds between the oxygen and the hydrogen, and as a result, the water molecule has a partially positive end and a partially negative end. So it's a polar molecule. And because of this polarity, what can happen is the molecules can form hydrogen bonds between each other. They can also interact with ionic compounds and polar compounds to form solutions. So what can happen here is we can have a water molecule coming in, and what it can do is it can overcome some of the ionic bonds that are found between sodium and chlorine. And what happens is when it comes in here, it displaces or dissociates, we say, this chlorine ion, and water molecules quickly surround it. And these ions can then move around within the solution. Same thing happens over here with the positive ions. So both of these ions are able to move around, and when the water molecule can overcome this attraction between the ions, we see the substance is soluble. We're forming a solution. So here's a great example of a solution. We've got some kind of sodium chloride or some other type of ionic compound, and the water molecules overcome those forces between the ions. The water molecules surround the ions, and eventually we have a nice solution over here. So this is called an aqueous solution, AQ. So remember, that's the symbol we use for state when we have a solution. So it's not always the case though. In some substances, for example, silver chloride, the water molecules cannot overcome the attraction between ions. The ions stay put together. And as a result, silver chloride and other substances are said to be insoluble. They are not able to dissolve with water. So how do you know if something can be dissolved or not? Well, you look at something called solubility rules. So these solubility rules look at anions. So you look at all of these anions and it lists which of those anions are soluble with different cations. We'll look at an example in a little bit. So let's look at, for example, sodium chloride. So sodium chloride is a solid. You add it to water, and it quickly dissolves, forming ions. And you notice that there's one sodium for every one chlorine ion. Same thing is true with magnesium, except magnesium has one magnesium ion for every two chlorine because of the charge. And it can also occur with polyatomic ions. So here you're going to have a sodium ion and a nitrate ion. So this is very soluble as well. Now, if you're insoluble, what happens is if you try to place these compounds in water, they just fall to the bottom. We say that they precipitate to the bottom. So for example, silver chloride added to water will eventually settle to the bottom. The same thing is true with lead sulfate. Lead sulfate is not soluble. So what happens is it also settles to the bottom to form this precipitate. So we're going to be using these solubility rules to determine if certain substances are going to be soluble or insoluble. So let's just quickly recap some of these. So if you have a nitrate, all nitrates are soluble. There's no exceptions whatsoever. Let's look at halides. So if you're a halide, halides are all soluble except if they're associated with a silver, a mercury 2, copper 1, or lead 2 ion. Sulfates are also soluble except for these exceptions over here. Now sometimes the sulfides are, or so the anions are insoluble. So we have a whole series of these that are insoluble. And then you look for the exceptions that are soluble. So to really be careful when you're reading this chart. And you go through it, and again, what happens is you use this information to determine the solubility of the compound in question. So let's take a look at some examples now. So we've got all of these compounds. What happens when we put them in water? So we're going to have our solubility rules. Here we go. So the first one, we've got lead chloride, lead 2 chloride. So let's look at the halides. So chlorine is under the halides. We notice that they're all soluble except for these. And lead 2 ion happens to be 1. So what happens is this is a situation where when you place this in water, it's insoluble. It will precipitate to the bottom. How about copper sulfate? So you go through here, look for the sulfates. They're all soluble except for these. Copper is not there, so copper sulfate will be soluble. How about barium hydroxide? Well, you go up here, look for the hydroxides. Here we go. They're all insoluble except for these. So barium hydroxide is actually soluble. It can dissolve. Carbonates. Let's go into the carbonates. Look, find the carbonates. Here we go. They're all insoluble except for ammonium and group 1 elements. Well, this is group 2, so that means calcium carbonate is insoluble. And finally, we've got sodium phosphate. Forgot to check these. Phosphates are all insoluble except for ammonium and group 1. So sodium is group 1. So group 1 phosphates are soluble. So that's it. We're going to be using these solubility rules later to determine if double displacement reactions actually occur.